Hi everybody, this is Poornima and you're watching video lecture series on protection switchgears. Today we are going to discuss the topic of methods of neutral grounding. So come, let's go into the video. So here, why the power system earthing is needed? What is earthing and why the power system earthing is needed? So earthing is nothing but the power system grounding or earthing means connecting frame or electrical equipment, that is what non-current carrying part or some electrical part of an systems. That is example neutral point in a star connected system, one conductor of the secondary of the transformer to the earth. Okay. So grounding provides protection to the power systems. And earthing of an electrical equipment ensures the safety of the persons handling the equipment. So earthing is first thing is safety of a person who's handling the equipments. So grounding or earthing. So the process of connecting the metallic frame that is of an electrical equipment or some electrical part of a system. So grounding of connecting the metallic frame to of an electrical equipment or some electrical part of a system to the earth is called as grounding or earthing. So connection between the metallic frame and the earth is an earthing or grounding. So here comes the neutral grounding. We can say what is neutral grounding is the connecting neutral point to the earth, that is soil, is either directly or some circuit elements. Say that is the example resistance, reactance, Peterson coil, etc. is called as neutral grounding. So the neutral grounding provides protection to the equipments. So during earth fault, the current path is completely neutral. So when it is provided during any fault and the current path is completely neutral. So why are the advantages of a neutral grounding? The voltage of healthy phases does not exist line to the ground voltage. That is, they remain nearly constant. The high voltage due to the OR grounding and as eliminated. The life of insulation is long. The over voltage is reduced. It provides greater safety to personnel and equipment. It provides improved service reliability. Operating and maintenance expenditures are reduced. So these are the main advantages of neutral grounding. Here comes the methods of neutral grounding. Here first one is solid or effective grounding. The next one is resistance grounding. Third one is reactance grounding. And fourth one is Peterson coil grounding. And finally, fifth one is voltage transformer groundings. So this is very, very, very important grounding. Okay. So we can see one by one in this upcoming series. Today we are going to discuss about, as a first, we can discuss about solid or effective grounding. Here we can see solid or effective grounding. Here we can see star connected, and we have C R phase, Y phase, B phase, and we have neutral. So neutral is directly grounded. Neutral is directly grounded here. Here, if the fault occurs in this B phase, what happens? The fault current flows through this. Fault current flows through this, and other two phases are safety. Other two phases are safety. This is solid or effective grounding. So when there is the point, there is three-phase system is directly connected to earth soil, is called a solid grounding or effective grounding. When an earth fault occurs between the earth and any one phase, the voltage to earth of a faulty phase becomes zero, but the healthy phase remains at normal phase value, as already discussed. The fault current completely nullified by the capacitive current. The fault current is completely nullified by the capacitive current IC. Here we can see the capacitive current. Here we can see the capacitive current ICs. The other name is resistance grounding. The next type is resistance grounding. In order to limit the magnitude of earth fault current, it is common practice to connect the neutral point of a three-phase systems to the earth through a resistor. It's called as resistance grounding. Here we can see the diagram, the difference. So in previous, what happened? The neutral is directly grounded. Now we have grounded with neutral. Now what happened? The same process takes. So what happens? This limits the magnitude of the current. Okay. So when the neutral point of three-phase systems, there is three-phase generator, three-phase transistor is connected to the earth through the resistor. It is called as resistance grounding. This is what resistance grounding. So what is the advantages of this grounding is, by adjusting the value of R, what happens? By adjusting the value of R, the R ground can be minimized. It improves the stability and less interfaces and minimize the hazards. So these are the main advantages. And a disadvantage is the system neutrals is displaced during earth fall. The equipment has to be insulated for high voltages. The system is costlier than the solid grounding system. The large amount of energy is produced in the earthing systems during the fault. Applications where it is used is, it is used on a system operating at a voltage between 2.2 kV and 333 kV with the power source capacity more than 5000 kV. Okay. So these are the advantages, disadvantages, and of resistance grounding. So today we have seen two types of grounding. One is solid and effective grounding, or effective and resistance grounding. So remaining types of grounding we can see in upcoming classes. Thank you so much for watching.